Alrighty, let's do 3 more multiple choice problems. Which of the following is a solution to this initial value problem? Well, I think we might need to separate, integrate, solve, but you're not going to really enjoy this, I can tell already. So if I separate, I get dy times y. I'm going to erase what I just did there and do it right. dy times y equals ln of x over x dx. The reason why you're not going to like it is because this is a u substitution problem with u equals ln of x, du as 1 over x dx. So I'm really integrating u du, which goes to u squared over 2. So my integral on the right is ln of x squared over 2 plus c, and on the left is y squared over 2. So now if I multiply all the way through by 2, I'm coming up here, I get y squared equals ln of x all squared equals twice some constant c. And then I would take this, not equals, plus some constant 2c, or twice some constant c, so 2c. And then y squared, if I take the square root, I end up with, y of 1 equals 1, sorry. ln of 1 is 0, so that means c is going to have to be 1/2. Is that right? Let's see. If y of 1 equals 1, plug in a 1 here, I get out 0. Plug in a 1 here, I get 1. That means c has got to equal 1/2. And that means I have y squared equals ln of x squared plus 1. So then if I take the square root of both sides, I'm going to end up with d. And notice it doesn't have the plus or minus. You don't need that because the particular solution lies on the positive half of the curve. So you only need the particular solution that is relevant. Okay, and number 5, another separate, integrate, solve. So we're going to have dy over y squared equals sine x dx. So left side integrates to negative 1 over y. Right side to negative cosine x plus c. If I take the reciprocal of both sides, I'm going to get negative y equals 1 over negative cosine of x plus c. Then if I multiply through by a negative, I get y equals negative 1 over negative cosine of x plus c. So now let me use my initial condition, 0, 1. I get 1 equals negative 1 over cosine of 0 is 1, so negative 1 plus c. And in order for that to equal 1, I need my c to equal 0. So my c is gone. So then, what is y of pi? So plugging in pi, I get y equals negative 1 over negative cosine of pi. Cosine of pi was negative 1, so I end up with negative 1 over 1. My answer is B, negative 1. And then the last problem on the page, dy dx equals e to the y. Separate to get dy over e to the y equals just dx. E to the y is really e to the negative y. Might help you guys to look at it like that. So that integrates by undoing the chain rule to negative e to the negative y. Then the right integrates to x plus c. So if y of 0 equals 1, then I find that negative e to the negative 1 equals c. So my c is negative 1 over e. So let me rewrite this problem. I have negative e to the negative y equals x minus 1 over e. Now I've got to solve for y. So let's multiply through by a negative. E to the negative y equals 1 over e minus x. Take the ln of both sides. I get negative y equals the ln of 1 over e minus x. And then multiply through by a negative. So y equals negative ln of 1/2 minus x. And I'm looking at this and I'm wondering if any of these answers actually works. And I'm not convinced that it does. Okay, so I just went and checked the key, and the key says that C is right, but I think that C is not right. It's the general format that you get, but the constant is wrong. So there is no solution to this one that's correct. If we had had this as a 1 over E, then we would have been all set.